Hello, people. I believe you're enjoying it so far. I believe what I'm teaching is making sense. I believe you're understanding what I'm teaching. I believe you're not finding it difficult implementing stuff on your own. And the reason why I don't share this code with you is because I want to encourage you to write the code from scratch on your own. When you read or watch something, you remember, I think, 38% of it. But if you write, I heard you remember about 78% of it. And if you watch and write it several times, you remember, is it 97% or something? I don't remember my figures very well, but at least once you have sat and coded from scratch, it reinforces the understanding in your mind. And even for myself, as I teach you, I never forget what I teach you. Because once I teach you and I help other people to understand it, there is no way I can forget what I have taught somebody. Okay, so teaching on YouTube is one way for me to also reinforce what I have learned in the past. Okay, so I am not going to share the code with you, and I encourage you to write it from scratch. It is going to help you to reinforce the understanding and be able to implement stuff on your own. Okay, good. So in the previous video, this is where we ended. We calculated the color histogram of a grayscale image, and in this video I'm going to show you how to calculate the color histograms of a colored image. Histograms because a colored image have three channels: the blue, the green, and the red. Okay, the BGR channels, and you want to calculate the histograms of each and every one of these. Let me kill this and show you how to do that. So the most important thing is the calc hist function from CV2. Okay, we use 0 here because it is a grayscale image, and once we put 0 there, grayscale image doesn't have channels, so it will calculate the histogram with the pixel values between 0 to 255. But for a colored image, we have to calculate the histogram for the blue channel, the green channel, and the red. To have this image in the colored format, we don't have to read it in grayscale. So I'm going to get rid of this red grayscale. Okay. And I will get rid of this CMAP gray because we are not rendering a grayscale image anymore. And then, like I told you, we have to calculate the blue histogram first. Okay, because the first channel in a colored image read by CV2 is the blue. And then we will do the same thing for the green, which is 1, the second channel. Mind you, we are counting from 0. So this should be the green histogram. And I'm going to do the red histogram. That is going to be the third channel. Mind you, CV2 rates images in BGR, blue, green, and red. Okay, so when we come here, we need to plot the histogram for each of these channels. So I'll plot for the blue histogram, and I want that plot to have the color blue. And when I use B in matplotlib for color, it is blue. Okay, and I'm going to plot that of the green. Don't do what I'm doing. Don't copy and paste. It's a bad behavior, I know, but I'm doing it anyway. And I am going to, sorry, you see why I said don't copy? I copied the wrong stuff and I pasted the wrong stuff. I'm going to copy red hist, and I want to render that in red. Okay, so let's hope everything is all right, and let's run our program again. Histogram, prepare images, red hist. Sorry, this is supposed to be 2 because we are counting from 0. So you see, it found out that there is no fourth channel. Once I said 3, I am referring to the fourth channel. So look at this. It is beautiful. Beautiful. How do we interpret this graph? The blue line is telling us the pixels that have blue component in them and their distribution. So this tells us that we have quite a good number of pixels that are blue, and as you can see, a lot of the spectators are in blue and the Barca shirt itself is in blue. But wait, the color here is not showing exactly what is seen in the original. And guess what? Why is it showing this way? It is showing this way because OpenCV reads in BGR format and Matplotlib plots in RGB format. So actually the channels have been swapped out. So this image is not what we read. Let's fix this and come and show our graph again. So this is our image. It is BGR, okay? But this guy here has to render our image in RGB, okay? It has to render it in RGB. So how we can do this is say RGB, that's the image in RGB, is going to be cv2.cvt color, and I'm going to convert my image from cv2.color bgr to RGB, okay? And then we would rather show the RGB here so that we can get the natural colors of how the image appeared, okay? Yay! So now we have the correct colors showing in our image. And look at the graph. You know, diagrams do not lie. By looking at this graph, you can tell how much green is in the picture, how much blue is in the picture, and how much red is in the picture. And do not be fooled about how high this red is here, and you are not actually seeing enough red apart from the red in Ronaldinho's jersey. Actually, there is a red in his face. There is a red component in many of the colors here. I told you that a mixture of red, green, and blue in different proportions can give you different colors, okay? So you don't always have to see pure red or blue or green to believe that there is some blue or red or green in there. Actually, there is almost always a component of red, green, and blue in there. And you can see the blue, there are a lot of blues, pure blues in the shirt, and some of the spectators, of course, they wear their team's jersey to come and support them. Okay, so it makes sense. And green because they are playing football, and football is played on a green field. Okay, so there are a lot of greens in here, and it's a shade of green, some very deep, some very light. And basically this is how to calculate the color histograms for a colored image. Let's go over the code once again. This is very similar to how I did it for the grayscale images, except the fact that I had to convert the image from BGR to RGB because Matplotlib renders images in RGB format. So I converted the image I read here into RGB and I rendered that. And over here, I had to calculate the histogram for the blue, the green, and the red channels separately. And how I did that was if I specify 0 for the channel that is blue, if I specify 1 that is green, so BG, and 2 is R, that is the third channel, and I had to plot for each one of them. in different colors so that I'll be able to distinguish between them. So thank you very much for watching, and I will see you in the next video.